Why does the moon follow us when we drive? As we rush down the road, we notice how everything flies past us in the opposite direction: trees, houses, fences, the road. And from the moon, too, we expect it to fly past us, or at least go backwards the farther forward we go. When it doesn't, we feel as if it is following us. The moon may not seem to be very far away from us, but the average distance from it to Earth is 384,400 kilometers. This enormous distance explains why, when we drive a car and look at the moon, it seems as if it is following us. Compared to the distance our car travels in a few minutes, this distance is enormous. So as we drive, the angle at which we see the moon remains virtually unchanged. And while everything flies past us, there is a sense that the moon is following us. Why does the moon raise huge masses of water, but they don't fly out into space? The cause of the tides is two things: 1. The uneven distribution of the gravity of the moon on the surface of the Earth. 2. The centrifugal force that occurs as the Earth rotates around its axis. The influence of the centrifugal force is small and causes only a constant rise of the water level at the equator compared to the poles. But the heterogeneity of the lunar gravity is determinative. As an example, we can say that when the moon is over the Atlantic Ocean, its waters will be subject to a greater force of attraction than on the waters of the Indian Ocean, which at that moment is on the other side of the globe. The Earth's gravity also plays a role. Since it is many times greater than the lunar gravity, it does not allow the waters of the oceans to fly up towards the moon. As a result, the water only rises a few meters higher, but does not fly into space. Why don't the artificial satellites, which orbit us, collide with each other? Currently, over 3,000 active satellites are orbiting the Earth, and an equal number are already out of orbit. In all, there are more than 100 million fragments in Earth orbit. These fragments are space debris ranging in size from 1 millimeter. The size of the near-Earth space is quite large. But if you consider this space in numbers, one satellite or object is about 13,000 cubic kilometers. That's not much, a little more than half the volume of Lake Baikal. And given a velocity of over 28,000 kilometers per hour, the chances of a collision would be quite high. For example, in 2009, the Iridium satellite collided with a spent spacecraft. The results of this accident were the destruction of the satellite and 2,300 pieces of large space debris.